Howdy, partners, back for more, are we? But in this discussion, in this video, we're going to talk about some of the associative organs of the integumentary system. So that's the hair, the glands, and the nail. And this video specifically, we are going to delve into and swim in the waters of the hair. So hair is an epidermal derivative. It is a keratinized epithelial tissue. So epidermal derivative derived from the epidermis, obviously, and it's keratinized, epithelial tissue. So the all of our hair does have melanocytes. Remember, melanocytes produce the melanin, that ultimately cause the coloration of not only the skin but the hair as well. And hair, last but not least, is avascular, and hair's pretty much found everywhere on the body except a few places: the palms of the hands, soles of the feet, lips, nipples, and some part of the genitals as well. So just pretty much areas that have that tougher skin is not going to have hair. So palms of hands, I almost said palms of feet. Palms of hands, soles of feet, lips, nipples, and some areas of the genitals. But the functions of hair, there's a few functions here. So thermoregulation, obviously. We got these wool around us to help keep us warm. It's like we're wearing a big Snuggie all the time. Kind of reminds me of the cheetah Snuggie I have. But protection is another function. So just for example, think like the eyelashes keep debris, dust out of our eye. Nice eyebrows here, keeps things from dripping into the eye, sweat dripping into the eye. Nose hairs, sometimes got quite a few of them. Those also aid in trapping debris, dust going into our nose. So they are a protective mechanism. Hair is how people identify each other. So think if nobody had hair, it would be very tough to determine one person from another. I don't know if I'd know my sister from my dog or my dad from my cat, but so hair is major key in identifying people. And last but certainly not least, hair stimulates sensory receptors. So hair are not sensory receptors, but they do the movement of hair vibrates to and stimulates sensory receptors. So we feel something on our skin, the hair vibrates to and stimulates the sensory receptors, which are below the surface there. So hair functions, thermoregulation, protection, how we identify each other, and also stimulates sensory receptors. So we're going to finish off this mini epi here with discussing the structure of hair. So there's 4 different parts. There's the bulb, the root, the follicle, and shaft of hair. So bulb, it's the base. It's the base of the follicle. The bulb is dermal papillae. So if you remember that from a few videos ago, dermal papillae, it'll help supply oxygen and nutrients to help the hair grow. So we got the bulb. This is if you want to think of an analogy of we're gonna have a running analogy here. Think of standing in a pool. While you're belly button deep here. So in this case, the feet on the bottom of the pool, that base would be the bulb. So this bottom part is the bulb, and then the root is below the surface of the skin. So it's the legs that are underwater, if you will. So above the bulb, but still below the surface of the skin. Follicle does surround the root. So think of this as like the bathing suit that's around the leg. So it covers the root, the parts that's below the skin, and just acts as kind of protects it, supports it. And then the shaft is the part of a hair that is above the surface of the skin. So in the analogy case of the pool, it's the upper body that's above water. So it goes the bulb, and then we'll say this is the surface of the skin. So we got the bulb, the root here, the follicle, which is surrounding the root, and then the shaft, which is above the skin there. So bulb, root, follicle, and then the shaft's above the skin there. So it's pretty simple, straightforward. But that bulb, just recall, it is dermal papillae. So this is what helps the hair to grow. It is avascular, so this is the key that allows hair to grow, the bulb of a hair. So that's hair, epidermal derivative, avascular, has melanocytes to color it. It's keratinized epithelial tissue and functions thermoregulation, protection, how we ID each other, stimulates sensory receptors, and then the structure of a hair. We got we'll go top down actually. So we got the shaft, the follicle surrounding the root, which is below the surface of the skin, and then the bulb, which is the base of it all. And that's our discussion on hair. We're going to continue with the associative organs after a few short words from our sponsors. Hey, shit, actually, good thing we didn't leave yet. We got the piloerector muscle I want to discuss real quick. Piloerector muscle, so it is a muscle. It attaches to the epidermis and the proximal end of the hair. So we got, I'll just draw it out now. So we got the epidermis layer. We got the hair below the skin here. So the piloerector muscle might be over here. It attaches not only to here, but here also. So it kind of goes something like that. And this is pretty much what goosebumps are when the hair stands up in our body. So think of this on the surface of the skin. This muscle contracts, the piloerector muscle contracts, which pulls the proximal end of the hair towards it, and causes the hair to stand up. So on the surface of the skin, the piloerector muscle below it contracts, which causes the hair to stand up because it pulls it, and it just kind of pulls up like that, the hair on the skin, and this does aid in thermoregulation. So whenever we get these goosebumps and the hair stands up, there is a anatomical reason behind that, physiological reason, and that's due to thermoregulation there. So piloerector muscle attached to the epidermis, proximal end of the hair, so the hair that's part of the hair that's closer to the bone, if you will, the deeper part of the hair. And yeah, whenever the muscle contracts, hair stands up, aids in thermoregulation there. So yeah, in next episode here, we're going to continue our discussion on associative organs. I'm for real this time.